Hello students, this is the last lecture under the series metals and non-metals, and this is sixth part. So with this we will finish this chapter, metals and non-metals. So first of all, we have done extraction of metal in low reactivity series, medium reactivity series and high reactivity series. So metals, different processes are adopted and metals are extracted in these three different categories. But the metal we get from different extraction processes, they are not very pure, and we have to further purify them or refine them, and this refining is mostly done by electricity. That's why it is known as electrolytic refining. The electrolytic refining of the metals like zinc, copper, tin, silver, it is done, which we get from the extraction processes. But some metals like gold, they are found in free state in nature, but they are not very pure, though they are not combined with other chemicals or other metals, but still they are not very pure. So even the metals which are of very low reactivity series, at the bottom of the series, they are also to be refined, and the metals we get from the extraction, they are also to be refined. The refining process is same for these and for this and these both, and it is electrolytic refining. This is, I have drawn an electrolytic cell, and electrolytic refining of copper has been shown here by this figure. So what is there? This is a container or a vessel or a beaker you can take, and these are two electrodes. You know very well now. Normally in an electrolytic cell we make electrodes of graphite, but here as the purification or refining is done, this is of copper. So both the electrodes, they are made of copper, and this is at anode, this is cathode. All of you know anode is plus and cathode is minus. So on anode, a thick plate or thick lobe of impure copper is kept, which we have get from extraction. So this is a thick block of impure copper. It is attached at anode, and on cathode a very fine thin strip of copper is kept. This is the electrolyte. Electrolyte is copper 2 sulfate, CuSO4 aqueous solution. It is CuSO4 aqueous solution which is slightly acidified so that the electrolyte can pass easily. So this is the electrolyte, copper sulfate aqueous solution, acidified. These are two electrodes, anode and cathode, impure copper, very pure copper. And now how this purification is done or refining is done. First of all, this CuSO4, it divides into, break off in ions. Copper ions and sulfate ions both are separated in this vessel. This is an electrolyte, this is the salt solution of copper. So copper and sulfate, they become separated when electricity is passed. This is the cell and electricity is passing. This is the negative end. And so what happened? When copper and sulfate, they are separated, then from in the solution, then what happened? Where it is written? In solution. So from solution, these copper ions, These are formed ions from solution. These copper ions Cu2 plus. Why it is written as Cu2 plus? Because the valency of copper is 2. So these Cu2 plus ion, they come to this thin copper plate along with 2 electrons. And when the electrons, they are added to the ion of the copper, then copper atom is formed. Neutral copper atom is formed. This neutral copper atom, it is attached to this cathode. The cathode starts fattening. The copper, the pure copper, starts depositing on this thin copper plate. And when in the solution, the copper ions, they are lacking, they are decreased, they are less, then what happened? From this anode of impure copper, the same amount of copper ions, they start dissolving in the solution. These copper ions with electrons, they start coming in this solution. From here, these are then taken up by this cathode. In this way, the process is going on. The copper, it is released from this impure and it is getting deposited on this pure cathode plate or pure cathode thin strip. In this way, all the copper from here, it is transferred to here. It becomes thick, very pure copper, about 99%, and this become a thin strip. Afterwards, this strip is changed with other impure copper block. So this is how the copper from here comes here and deposited on this cathode. Now the impurities which are present in this anode, if they are soluble, they are dissolved in the solution, and the impurities which are not soluble, they settle here below this anode, and now this is known as anode mud. So what is anode mud? Anode mud are the impurities which are insoluble in this solution and they are released from the impure copper block at anode. That's why they are known as anode mud. In this way, refining or purification of copper is done. If we want to take some other metals like zinc or silver or gold, then the impure block will be kept here, a pure strip will be kept here, and here the salt solution of the corresponding metal will be taken. So from the salt solution, pure metal will be deposited here, and to fill the gap from impure block, the metal will come into the solution. In this way, a circle goes on and this becomes fat and pure, and this is destroyed or this is finished, and we have to put again the impure block. In this way, electrolytic refining of metals is done. I have written two equations here. You just look at them. What is happening at cathode? This is cathode. What is happening at cathode? That the ion, copper ion from the solution. This ion, where from it has come? It has come from this electrolyte, copper sulfate solution plus electrons, and a neutral copper atom is formed at cathode and it is deposited at cathode. And what is happening at anode? At anode, the copper, it is released from here, and when it comes into the solution, it breaks up into copper ion and electron. Copper comes from anode into the solution, breaks up into copper ion and electrons, and this is then come to in the solution, and from the solution to the cathode. In this way, refining is done and pure copper is deposited on cathode. This is about electrolytic refining of metals. Very simple and very easy. Now the next topic here in metal and non-metal very simple topic, and it is corrosion. You know corrosion. You have studied it in lower classes also. Very simple, just बच्चों का खेल. So what is corrosion? Corrosion is slow and gradual eating of metal surface due to the activity of air. So if some metal, all of you know, suppose this is iron nail made up of iron. If it is kept in open air, in open atmosphere, after some time, what we see? We see that a brown, reddish brown flakes, they are deposited on this copper nail, and we say it is rusted. What is this rust? Rust is corrosion of iron. So how can we define corrosion? Corrosion is slow and gradual eating up of metal on their surface by the action of damp air. So this is how corrosion takes place. Many metals, they corrode, and normally it is a non-desirable process. Why non-desirable? Because once on metal surface this rust or some chemical is formed, it gets away from the surface and metal is eaten away. So metals, they are slowly, they become less and less. So this is a non-desirable process. But sometimes in some of the metals it helps also. How? As on aluminium. With the action of air, aluminium oxide Al2O3 is formed, which forms a protective layer on aluminium, and further the aluminium does not corrode. Likewise in zinc also, ZNO is formed and it is no further deterioration of metal takes place. Likewise in silver also, silver sulfide Ag2S is formed, and copper also, copper carbonate is formed. So in some metal, it helps the metal which they do not further deteriorate. But in iron, like in iron flakes, this rust flakes are formed, they detach from the surface and again the surface is corroded. So after some time, these iron, it gets completely deteriorated, like the bridges or some machine parts, if they are not taken care of. So this is how corrosion takes place, and I have written corrosion in different metals. What is the action of air? What is the name of the compound formed and how they look like? So first you can see here is iron. Most important, iron. So the corrosion takes place in damp air. What is damp air? It means air should be there, oxygen should be there. Damp means water or moisture should be there. So water and oxygen both helps in corrosion of iron. What is formed? Hydrated iron oxide, Fe2O3 XH2O. The rust or the flakes of rust are iron oxide, XH2O, known as hydrated iron oxide, and they are reddish brown flakes which from the surface they are dropped, they are given away, and again the iron surface is exposed for corrosion. Second is aluminium. It also corrodes in damp air, but aluminium oxide is formed on the surface. It is a dull covering and it is a protective covering. It doesn't gives off from the surface, and a protective covering is formed so that aluminium does not corrode further. Copper reacts with carbon dioxide of air. When carbon dioxide and water both react with the surface of the copper metal, what forms? Copper carbonate mixed with copper hydroxide. This hydroxide is due to water, carbonate is due to carbon dioxide. So the corrosion formed on the copper is CuCO3 CuOH whole twice. It is a green covering. You must have seen the copper utensils which are green in color, and it is also a protective covering. Then the next in series is silver. We have seen the silver jewelry, it becomes black after some time if it is exposed to air. So from air, this silver reacts with hydrogen sulfide gas. The air is damp and hydrogen sulfide gas reacts with silver, and silver sulfide is formed Ag2S, and this silver sulfide is black in color. So the surface of the silver jewelry, it becomes black after some time. Next is magnesium. Magnesium formed magnesium oxide in damp air with the reaction with oxygen, and it is again a dull covering, and it is protective also. Likewise, zinc also. Zinc metal, when it reacts with oxygen of the air, it becomes zinc oxide, which is dull, and it is also protective. So this is how different metals, they corrode due to the action of air. Now how this corrosion can be checked? How we can check this corrosion? There are many methods. The simple methods all of you know. The metal can be oiled. Oiling can be done on the surface. Painting can be done. You must have seen the big bridges or machine parts or the motors. They are painted with different paints, red, blue, green, and due to this painting, the surface is blocked and air cannot work on the surface. So oiling can be done, painting can be done, greasing can be done, then anodizing can be done. Anodizing is covering the metal surface with aluminium. This is known as anodizing. Then galvanizing is done. Galvanizing is done, and this galvanizing is covering of the metal surface with zinc coating. What else? This is fifth. Then alloying is done. We will just discuss what is alloying. And then chrome plating. Chrome plating can be done with chromium. So oiling, you know, to put oil, painting, to put paint, greasing, to put grease, anodizing with aluminium. The metal is dipped in aluminium. It is generally done by electrolysis. So electrolytic anodizing is done by aluminium. Galvanizing is with zinc. First zinc is melted to liquid, then the substance which is to be galvanized, it is dipped in zinc, taken out. Like you must have seen buckets. In olden days, iron buckets were there, or iron boxes or something were there, and they are galvanized with zinc, white, silvery zinc. And after cooling, this zinc forms a thick layer on the metal or iron substances, and now they cannot be corroded by the atmospheric damp oxygen or damp air. So, but one thing happens, sometimes it is asked in the exam also. Suppose this is a iron plate and it is galvanized with zinc. What happened? Sometimes a crack may develop. After galvanizing, a crack may develop on this iron plate, and this iron is exposed to air, but still it is safe. It is secured. Why it is safe? Because zinc is more reactive than iron? You know, zinc in the reactivity series is above iron. So zinc is more reactive than iron and it forms zinc oxide before iron forms iron oxide. So first zinc oxide is formed in this crack, and zinc oxide, it forms a dull and protective covering. So no further deterioration of iron plate is done, even if after galvanizing there develops a crack. Sometimes it is asked in exams also. So this is how galvanizing with zinc is done. Then chrome plating. You must have seen many machinery parts or handles of the doors or knobs which looks like stainless steel, but in fact they are not of, or the cycle handles, but they are not of stainless steel. They are chrome plated. With chromium. Chromium is a metal. By electricity, these metal, iron or other what is that? Aluminium. These metals, they are chrome plated for their shining and for non-corrosion. Once the metal is chromium plated, they do not corrode. So chromium plating is done like this, and next is alloying is done. Now we will see what is this alloying. Alloy, do you know what is alloy? Alloy is a mixture of two or more metals or metal and non-metal. Are you understanding what is alloy? Alloy is, what is alloy? Alloy may be metal plus metal, it will form alloy, or metal plus non-metal, it may form alloy, and the number may be more than 2. Then alloys are, it may be 2 or the number may be more than 2, then the alloys are formed. Why we form these alloys? Because they change the property of the metal. For example, we have seen iron. Iron is there or steel is there, it is very soft. When in pure form, it is very soft and it corrodes or it rusted, all of you know. So if some machine parts or some valuable parts are to be formed from iron, then it is due to its softness and rusted nature, we cannot use iron alone. If small carbon, even 0.05%, it is a non-metal. So if this small quantity of carbon is added to iron, it becomes hard and strong, and this is known as carbon steel. So this carbon steel, it is used for making different machine parts, shafts, flanges, and which are used in heavy machinery shops. So when this small quantity of a non-metal carbon is added to carbon, a hard alloy we can get. So this is how alloying is done for changing the property of the metal. You have studied electricity and you have studied nichrome wire, which is used in some electrical gadgets like iron, oven, etc. This nichrome is, this is also an alloy. Alloy of nichrome, chromium, manganese and iron. So these four metals, they combine together to form nichrome, and the properties of nichrome is changed. It is having a very high resistance, and also the alloys, they have low conductivity for electricity. This is how the property of the metal is changed. Now it is non-corrosive, it may be hard, and the electricity, this conductivity for electricity is less. So this is how the properties of metal, they are changed. Alloys, how these alloys are formed? These alloys are formed by melting the main metal. The base metal is melted, become liquefied. Then in this very big furnaces are there. From there, in blast furnace or many furnaces, this is done for making alloys. And this melted in this molten metal, the metal which is to be mixed, it is mixed in molten form, and after it is cooled and alloy is formed. We know very many alloys which we use in our day-to-day life, like brass. All of you know pittal, that is an alloy, brass. Then bronze is an alloy. Even the gold jewelry we wear is an alloy, because the pure gold is very soft. Jewelry cannot be made with a pure gold. So some quantity of copper or silver or both, they are added with gold to make it hard so that jewelry can be made. And what are the other alloys? Bronze, brass, gold, and there are the solder which is used for welding. So many are this nichrome we have talked about. So there are many alloys which are used in our day-to-day life. I have a list for different alloys. You copy down this list and composition. Here we have composition of different alloys. What is mean by composition? It means what is the percentage of different metals in different alloys. So we will write 4-5 alloys to know the exact percentage or approximate percentage of different metals. The first is, we can make a table. The first we will write the name of the alloy, then composition, then its properties, and then the uses of alloy, where it is used. So we will make a table in a tabular form, so it will be easy for you to learn all the alloys which are asked in exam. Only very few alloys we will write. First is brass, a very common alloy, brass. It is formed by copper 80% plus zinc 20%. These are the approximate values. So by these two metals, both are metals, brass is formed. This is malleable. Do you know what is malleable? Can be a sheet can be formed by malleable property, malleable and strong. And uses, all of you know, pittal, brass, they are used for utensils, statues, and many other use. So this is the first, brass. Second is bronze. Bronze, I don't know what we call bronze in Hindi. I don't know. So copper is 90% and tin. This is the symbol for tin, SN, it is 10%. You can write in bracket tin. Tin SN is 10%, bronze is 90%, and this is a very tough alloy and also corrosion free, and it is used in a very important for making propellers of ships. Propellers of ships and other propellers. Propellers, do you know? A fan like which cut water in ocean or sea so that the ship can move. Very huge, about 20 tons, 30 tons. Fan like structures are there, and these are known as propellers. So these bronze, they are formed for making propellers and even coins. Coins are also made from this bronze, so because they are corrosion free and they are quite tough, they cannot mold. The third is solder. You must have heard the name soldering. What is soldering? When these are, suppose this is electric wires. To weld these electric wires, to join these electric wires, soldering is done. So it is used for electric circuits. Soldering is to join electric circuits with one another, and it is lead. Do you know the formula of lead? Lead 50% and tin. Again the same tin, it is also about 50%. And what is the use? Why this solder is made? It has very low melting point. So rods are made, solder rods are there, and they are used for welding in electric circuit or in any circuit. For welding these solder is an alloy made up by tin and lead. Now the fourth I can write here, steel. I have give you the example formed by iron and non-metal carbon. It is hard and strong and used for bridges, buildings, machine parts, etc. Machine parts, etc. So this is how, these are some, we can write 1, 2 more. Fifth is stainless steel. Very important. Stainless steel. All of you have seen the utensils in our houses. Most of them are of stainless steel. It is, in short, it is known as SS, and many grades, 316, 30, 204, 304, many grades of stainless steel are there depending upon the percentage of nickel and chromium. So how stainless steel is formed? By iron, nickel and chromium. So these three, they are joined in different proportions for making different type of stainless steel, and one of the important is rust free, non-corrosive and strong and rust free, and made for, it is used for making utensils and instruments also. You must have seen medical instruments. Medical instruments are also formed by stainless steel. So this is the fifth one. One more we can write, very important, very expensive, and that is gold. And gold, it is 22 karat gold. In India we use, gold is pure substance, pure metal. 22 karat gold is alloy. In India, 22 karat gold is used for making jewelry. So this is gold, some silver and copper. They are mixed with gold, and this gold is now hard and strong, and it is used for making jewelry. So this is how. And one more you write. It is written in NCERT, I think. When mercury is present in alloys, these alloys, they are known as then amalgam. What are amalgam? Amalgam are when mercury is present. This is the symbol of mercury, and silver, zinc and even sodium. So all these four form amalgam, this amalgam is very hard. This amalgam is formed which is very hard, and normally dentists use this amalgam. I think for filling purpose or something, dentist, they use this amalgam alloy because it is very hard. So these are composition of different alloys. You have to learn them with their percentage. Sometimes it is asked in exam. So with this chapter is completed. We will take further some new chapter. So this is all for today. Thank you.